Welcome to part 2. We'll start with number 4, a binomial situation where we are flipping a coin 10 times. Of course, flipping a fair coin, probability of success is 0.5. Here we're talking about getting heads. And instead of asking for a particular x, all the x's here are given in a distribution. And before we look for, by the way, A is not the right answer, what would we expect to see? What is the most likely, right? The average, if you just take n times p as the average, you would expect 5. So this should be the highest number. And as a matter of fact, if we did this in histogram form, we wouldn't expect very many zeros or very many tens, and then this would just step up. Now, this is not the theoretical counts. This is someone actually doing it. So we're not going to see perfectly here, but out of 100, we expect something like 25, and then these would drop down to 21, and and so on and so forth. So we're looking for a high here in the middle. Basically, can you do a bell curve in the form of a frequency table? Okay, so not A. Turning the page, how about B? Well, we've got a little bit higher, but no, this is too uniform, right? So if we were going to graph these, this is not a binomial curve. Now, C looks like the right answer, right? We've got almost nothing down at the 0 and the 10. I'm sorry, literally nothing. And then we've got a high in the middle here. So this is, it's not really a curve, but if we were stepping up in a histogram, this is a distribution that looks like this. Number 5 is asking you if you can identify all the parts of a binomial formula. And that requires reading this, right? So this would be P, the probability of success. And what is success? It's finding someone who is 25 years or older. And we are talking about that event. And there's our number of successes. So we know that X and P go together. We're talking about finding 40 out of 50. So that makes A the right answer. The P and the X go together. And I suppose we could write out what the binomial formula is here. Choosing X out of a total of N. That would be the number of combinations. And the probability of just getting one of those sequences would be 31% times itself 40 times, and then the other 10 that aren't what we're looking for. 69% chance, 10. Number 6 throws a percentage at you and then asks you about mean and standard deviation. And reading through the problem, we should identify this as a binomial situation. We are checking these households, and it's yes or no. Do you have a computer or not? And we have a steady probability of success. Each household we check, we expect 85% chance. And so what is mean? Well, I've written the formula over here. And, here's a distractor. Oh, well, we expect 85. Well, no, 85%, and we're trying it 200 times, so you have to multiply the 85% times 200, which gives you 170. So already we know that it's none of these. So it's D or E. How would we find standard deviation? Well, the formula for that, square root of n times p times q, which is 170 times the 0.15 here. And that gives you something a little bit bigger than 25. And square root of 25.5, I believe, would be this one. Number 7. And one of the skills we're really testing here is whether or not we can figure out, well, I shouldn't say not, but what does it take to figure out whether we're dealing with binomial, normal, geometric, or none of the above. And for geometric, we should have these red flags that waving to us. And until is a key that this is probably geometric. All right, so we're going to roll 2 dice until we get doubles. Now the probability of getting doubles is it's out of 36, but there's 6 different types of doubles, so 6 out of 36 is 1/6. And we're talking about what? 3 rolls. What is the probability that it takes 3 rolls? Well, that means the first two would be not doubles, and then finally doubles. So this is geometric probability, and usually, we see it in the form of this to some exponent. So failure, 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 how many times? So that's really Q raised to the 2nd power, and that is, it's a little bit tricky that they put it out of order because the 1/6 really is coming 3rd, but that answer is letter D. Again, the key here is reading and figuring out, are we dealing with binomial, geometric, normal, or something else? And we read along here, 47% is our probability of finding someone. Could be binomial. And then we're talking about selecting people one at a time until, and then we stop, right? We find someone, and that's it. So what does that mean? That's geometric. And then they're asking us for an average. So when we're talking about a geometric distribution, the mean is just 1/p. And if you think of this as a fraction, 47/100, I mean, you could put 1/0.47 and get the answer, but I just want to point out that this is the reciprocal of p. So 100 divided by 47 gets you 2.13.